Hello everyone, Namaste. I am Ramnath who would like to share with you some useful information on DPMO and Sigma, how it influences SoC design implementation. DPMO stands for Defects Per Million Opportunities. Sigma, as you know, it is standard deviation of the specific feature under consideration. I'll give you more details in the coming slides. A defective chip, if it gets in the field, it will be dangerous sometime as per the criticality of the specific scenario where it gets deployed. A defective chip caught at board level usually can make more damage. When the defective board by mistake is installed in a system, then the defective chip can make a lot more severe damage in terms of cost or sometimes in terms of life care. Chip yield depends on many factors. Here we will discuss for analysis purpose 3 factors which affect chip yield. Chip overall yield is affected by the individual stage or component yield. The defective parts in each stage, either stage 1 or stage 3 for example, need to be removed to get all good pieces that meet the chip requirements. So we need to find the yield for each stage based on the defective parts of that stage. With that information, it is possible to find the chip overall yield. The 3 stages broadly considered are functional, chip reliability, and chip test phase. So here we will understand that for the chip to function properly, setup, hold, removal, recovery, min pulse width, all these items need to be satisfied properly and there should not be any defects in this. Similarly, for the chip reliability operation, ESD purpose, ESD wise, aging wise, EM electromigration purpose, and latch up wise, in all these respects, the chip need to function as expected. Aside to that, testing time also, the chip needs to function as expected. So during scan shift, scan capture, IDDQ, at speed, all these stages also the chip need to function as expected. Then only we can get reliable chip yield. Based on that, the chip overall yield is calculated. So as we know, the semiconductor fabrication process variation affects these stages. Okay, so if you observe here, the standard deviation and the mean are calibrated in this way, and you can also figure out how the yield and the sigma are dependent on each other. So this is the perfect Gaussian distribution. Most of the times the distributions are not as normal as shown here. For example, for the delay distribution, it will be somewhat like this, and this is though appears normal but not purely normal, and here this is the decreasing delay and this is the increasing delay. Now this is the nominal delay for several distributed transistors in the chip. So chip overall yield is affected by the individual stage yield, which depends on the defective parts of that stage. So if you see, there are 3 stages in the flow which we have analyzed, and here we will understand that each stage defects per stage will depend upon the ppm. So here ppm stands for parts per million, which means number of defective units by number of total sample size into 1 million. So here if you want to calculate the chip overall yield, which consists for all these 3 different stages, stage 1, stage 2 and stage 3, cumulatively, then you have to multiply the yields associated with each stage. So if it is for many number of stages, then you need to do up to those many stages. So based on that, the chip overall yield will be obtained. Here, the higher the chip yield, overall yield, lower will be the DPMO. DPMO here stands for Defects Per Million Opportunities. So here DPMO is for a full process or flow containing all the stages, and ppm corresponds to per stage. So if you take the earlier example in the three-stage situation, the yield 1 of that stage 1 corresponds to 95% good, yield 2 corresponds to 93% good, yield 3 corresponds to 90% good. So if you observe these situations, then for the case 0, chip yield due to stage 1 and stage 2 is 88.35%, and the chip overall yield is close to 79.5%. This means like 79.5% chips doesn't need any rework or any repair. So they can be directly shipped to the customer, and they will meet all the requirements in terms of functionality, reliability, and test purpose. So coming to the another case, where in case 1, if yield 3 is made 99.9% good, then chip overall yield becomes 88.26%. Okay, so if you observe, heavy cost need to incur if one of the stage yield is made exorbitantly higher than the rest. Here the yield 3 is made very high compared to yield 1 and yield 2. So that means like yield 3 we are refining to a higher extent. That means like the sigma what we are employing during the SoC design stage is very high. So we are getting very high yield. So that means like we need to incur a lot of cost. This cost can be in terms of area or power or performance, whichever it is. Okay, so we are trying to make one of these very high, and thus we are achieving higher yield. So this is one situation which we should not do in general. And in the other case, where case 2, if yield 2 is made 94% and yield 3 is made 95%, then chip overall yield due to stage 1 and stage 2 equal to 89.3%. Here it is slightly improved, and chip overall yield for these three stages in the new situation is 84.84%. So it definitely is better than the earlier situation. And here the none of the stages are exorbitantly higher. Definitely it is not so high as the case 1, but it is much better than the case 0, and this is the most preferred situation because it will involve less of struggle here. Okay, here they are all made very close to the high value. That means like all the stages have almost the same yield value. So to improve such situation, we need to figure out which stage is having the lowest yield. So we will pick in this specific case, in the earlier situation, the stage 3 and stage 2 are having lowest yields compared to stage 1. So we will pick those two and we will improve upon them. So in this case they were improved, and so thus it became overall yield became higher. So these are the two observations we can have. So we can improve the yield, and thus we can make the DPMO lesser. So to get to this situation, we need to implement these during the SoC design phase appropriately. So sigma need to be taken appropriately for each stage of the design. These are the references I have referred to in making the current slides. I hope you will like it, and thanks to Tima also. And here are the different Six Sigma process, and where they explain the PPM and DPMO with more details and examples. It is worth looking at them. Thank you. Thank you for taking your time to go through. Bye. Yeah, feel free to provide your comments and feedback. Appreciate your